Okay, section 9.2 is the quadratic formula. So, like I said in the previous lessons, there's 4 methods to solving a quadratic. Remember, a quadratic is when you have a polynomial or an equation where the highest exponent is 2, so that's something being squared. And the 4 methods are factoring, which you know how to do. We talked about the square root principle. We just learned how to complete the square. And finally, we're going to refresh our memory on the quadratic formula. So the reason why we learn the quadratic formula is because it literally can be used to solve any quadratic function. It doesn't matter what it looks like, but you could use it on anything. Okay, so for quadratic in standard form, so that means it's x squared plus your bx plus c equal to 0. So it's in descending order set equal to 0. This is the quadratic formula. Hopefully you guys remember the song, right? The opposite of b plus or minus square root b squared minus 4ac all over 2a. Hopefully you remember it from when I taught it to you. You'll just remember my voice all the time singing the song or whatever teacher taught it to you. But the best way is to sing it to Pop Goes the Weasel. That's how I still sing it in my head when I'm doing these problems. Okay, so when you're solving quadratics using the quadratic formula, just like factoring, you want to make sure it's set equal to 0. Okay, meaning you want it in standard form. So you want it in order from highest exponent to smallest, and you want it set equal to 0, and that's how we find our a, b, and c that we plug into the quadratic formula. So from here, my a is in front of my x squared, my b is in front of my x, and then my c is the constant, the number that doesn't have a variable with it. So before I start plugging into the quadratic formula, you have to identify a, b, and c. Well, it's already in standard form. So here's my a, here's my b, here's my c. Okay, and then I'm going to take a, b, and c, and I'm going to plug it into the quadratic formula. So the opposite of b plus or minus square root of b squared. Remember, opposite, sorry, I forgot to say, opposite just means the opposite sign. So if b is positive, it's going to be negative. If b was negative, that's going to be positive. That's at the beginning. So then b squared minus 4 times a is 3, and c, which is negative 8, all over 2 times a, which is 3. So literally all you're doing is plugging in numbers, and then you're just calculating it out. It's so easy, especially if you have your calculator with you. So 10 plus or minus square root. So we have to calculate the inside of the square root first. So I'm going to multiply negative 4 times 3 times negative 8. I don't know why, but what I've experienced with most students is they multiply those numbers wrong because they don't understand that you're multiplying a negative 4. Okay, you're always multiplying negative 4 times 3 times negative 8. It doesn't matter what order you multiply it in, and you are not multiplying 4 times 3 and also by 8. A lot of people try to distribute that negative 4. Please do not do that. It is literally just multiplying 3 numbers together normally. So in your calculator, you're going to type negative 4 times 3 times 8. Okay, so I get 100 from the 10 squared, and from the negative 4 times 3 times negative 8, I get positive 96 all over 2 times 3, which is 6. I'm going to keep combining what's inside of the radical. So that's 196 all over 6. Well, I want to have my answer be as simplified as possible. I see that 196 is a perfect square, so always check to make sure, is that a perfect square or not, or can that radical be simplified? So the square root of 196 is 14 over 6. So all of these are like terms, so the 10 and the 14 can be combined, which means I need to calculate my 2 answers. Notice this plus and minus in between. That's going to set up my 2 answers. So I have negative 10 plus 14 over 6, and my other answer is going to be negative 10 minus 14 over 6. And then I'm going to compute that out. So I get 4 over 6, which I can simplify to 2/3. So there's one answer. And then over here, I get negative 24 over 6, which simplifies to negative 4. And those are my two answers. So if you end up getting rational numbers, so you don't have a square root left, that means that your original equation could have been factored. So I could have solved this by factoring. It actually would have factored out to be 3x and x and 2 and 4, negative 12, positive 12 minus 2, that gives me 10. And you could have solved your equation by factoring. But it just goes to show you that the quadratic formula works no matter what. So even though you can factor, the quadratic formula will work. But the reason why we also teach you the quadratic formula is because it works when you can't factor. Okay, so sometimes you'll have easier options. In this case, I want you to use the quadratic formula in this section, but from going forward after this, you should be able to identify when it's going to be easiest to use what method. Okay, so going back to this, these are my final two answers. Yes, I could have factored to solve it, but we're practicing using the quadratic formula because it works no matter what. Okay, so moving on to number 2, I can't identify a, b, and c yet because it's non-standard form, meaning it's not set equal to 0 yet. So what I got to do is move over this 14, and I get x squared plus 8x minus 29 equals 0. So in this case, I actually can't factor this, even if you wanted to. So no matter what, the only way that you could solve this equation is by using the quadratic formula. So I am going to identify my a, b, and c. So since there is no number in front of the x squared, remember there's an invisible 1, that's my a. Okay, and then here's my b, and here's my c, and I'm going to plug that into the quadratic formula. So x equals the opposite of b, so negative 8 plus or minus the square root of b squared minus 4 times a times c all over 2 times a, which is 1. Okay, so I'm going to calculate out the inside of my radical first. So 8 squared, that's 64. And then I have negative 4 times 1 times negative 29, which is positive 116, all over 2. Okay, and I'm going to combine 64 and 116, so inside of the square root I get 180 over 2. Now 180 is not a perfect square, so I need to simplify that out. So I need to see what is the biggest perfect square that goes into 180. So let me just kind of break this up a little bit. I know 9 and 20, but there's also a perfect square in 20, which is 4 and 5. So I'm going to combine the 9 and the 4. I'm going to make that 36 times 5. So 36 times 5 is 180. 36 is a perfect square. So I'm going to take the square root of 36. So I get negative 8 plus minus square root of 36. That's 6. So that's coming out of the radical. And inside of the square root, I still have 5 all over 2. So remember, you're looking at all the coefficients, and those could all be simplified by 2. So I'm going to divide all of those by 2. So I'm going to get negative 4 plus or minus 3 root 5. And then the 2 cancels out because 2 divided by 2 is just 1, and I'm not going to put that over 1. Now, you can only do that if all 3 of those could be divided out by the same number. Okay, if all 3 of those don't go in, have a number that go into all three of them, then you can't simplify any further. But since 2 went into all three of them, I simplified everything by 2, and my two answers could be written like this. The reason why you don't have to separate it into 1 plus and 1 minus is because you can't combine the 4 with the 3 root 5 because those are not like terms, right? The only way you could combine those is if they both had the same exact radical, which they don't, so that's my final two answers. Okay, number 3. Again, this is not in standard form. So I got to bring over the 12x. Remember, it's got to be in the correct order. So highest exponent to smallest. So 9x squared. I need the 12x to come next. Plus 4 equals 0. So I'm setting this up like a factoring problem. And now I need to identify my a, b, and c. So a is 9, b is 12, and c is positive 4. So x equals the opposite of b plus or minus the square root of b squared, so 12 squared, minus 4, a, which is 9, and c, which is 4, all over 2 times a, which is 9. Okay, and then we're going to calculate it out. So I get 144, and then I have negative 4 times 9 times 4, which gives me negative 144. So minus 144 over 18. Combine the inside. Well, 144 minus 144 is obviously 0, and the square root of 0 is 0 over 18. Well, do we really need to write plus minus 0? Because that's not going to change our answer whether you add 0 or subtract 0. So in this case, I just have negative 12 over 18, and I'm going to simplify that to be negative 4, negative 2 over 3. In this case, I only have one answer. No plus or minus, because the plus or minus went away with the 0. I literally have one solution, and it's negative 2 over 3. What that means is if I factored this out right here, I'd end up getting the same two things in the parentheses. So this would actually end up being 3x plus 2 times 3x plus 2. So essentially you do have two answers technically. It's just the same exact number. So it ends up just being negative 2/3. Okay, that's why that works that way. Okay, and then this last one, already in standard form for us. Here's my a, here's my b, here's my c. So x equals the opposite of b, so I get negative 8 plus or minus the square root of b squared minus 4 times 3, which is a, times 7, which is c, all over 2 times a, which is 3. So negative 8 plus or minus the square root, 64. Okay, and then negative 4 times 3 times 7, which is negative 84 over 6. Negative 8 plus or minus 64 minus 84, that's negative 20 over 6. Now, when you were a freshman and you saw this happen, you would say no real solution and you would be done. But now we're juniors and we know we could take the square root of a negative number and get an imaginary solution. So I'm going to simplify this radical to be 4 and 5, and the negative is going to come out of the radical as an I. So I'm going to take the square root of 4, which is 2. Then I'm going to take out that negative 1, make that an I, and then I have root 5 over 6. Okay, I'm looking at all three of these numbers now. Is there something that goes into all three of them? And there is. It's 2. So I'm going to divide all three by 2. So negative 4 plus or minus I square root of 5 over 3. Okay, since I cannot combine the numerators, those are not like terms, you could just leave your answer as is. And the plus minus represents your two different answers. So plus the I root 5 and minus the I root 5. Okay, you have a few U-tries. So I want you to pause the video right now, try these problems, and then come back and kind of test yourself and see if you get the same thing I do. Okay, here's my A, here's my B, here's my C. Well, B is negative 5, so the opposite of negative 5 would be positive 5. So positive 5 plus or minus the square root of B squared. Make sure you're putting the negative 5 in parentheses, because I remember a lot of kids freshman year doing this, and I'm sure people will still make mistakes this year, as doing negative 5 squared without the parentheses in their calculator and making that negative 25. But I want you to note to yourself, whenever you square this number in the radical, this is always positive. If that first number is becoming a negative, that means you're just typing it wrong in your calculator. Just know that you need to have the parentheses around your base number. Okay, so that should always be multiplying to be some sort of positive number. Okay, so negative 5 squared minus 4 times A, which is positive 4, times C, which is negative 6. Please, please, please be careful of your signs. It'll change everything in your problem. All over 2 times 4, which is A. Okay, so again, I'm going to simplify the inside. So again, you should be getting positive 25. If you got negative 25, please be careful. Okay, and then I have negative 4 times 4 times 6. So I get positive 96 all over 8. So keep combining. So 5 plus minus the square root of 121 over 8. I see a perfect square, so I'm going to keep simplifying. That becomes 11 over 8. Now, since I can combine those numerators, I got to come up with my two answers. So x equals 5 plus 11 over 8, and x equals 5 minus 11 over 8. So I get 16 over 8, which is equal to 2. And then I get negative 6 over 8, which is equal to negative 3/4. And those are my two answers. Again, since I'm getting rational numbers that aren't in a radical, that means I could have factored this on my own, but again, quadratic formula always works no matter what. Okay, and then number 6. This obviously is not in standard form, so I got to bring everything over so that it's set equal to 0. Please do not combine the x squared and the 4x. I still see people doing things like that, and by now, hopefully we know that those aren't like terms, so this becomes x squared plus 4x plus 6 equals 0. Not factorable, so you have to use the quadratic formula no matter what. Identify your a, b, and c. So a equals 1, b equals 4, and c equals 6. So opposite of b, plus or minus the square root of b squared, which is 4 squared minus 4 times a times c, all over 2 times 1. Plus or minus 16 minus 24 all over 2. So then I get negative 4 plus or minus the square root of negative 8 all over 2. So I'm going to keep simplifying this radical. So I'm going to break it up into 4 and 2. So negative 4 plus or minus the square root of 4 is 2, and I got to get rid of that negative inside of the radical. So I'm going to pull out the I, and then root 2 over 2. Okay, check all three of your front numbers. I see that they could all be divided by 2. So the negative 4 is going to become 2. The 2i is going to become I root 2 all over 1. And I'm just going to leave it as this. I'm not going to write it over 1. Those are not like terms. They cannot be combined. So I'm just going to leave my answer as negative 2 plus or minus I root 2. Okay? that's it for the quadratic formula. I made this chart for you that helps you determine what method to use. Now that you have all 4 methods pretty mastered for solving quadratics, it's good to know when's best to use what. So when you're want to solve by factoring, it's when the quadratic equation could easily be factored. So you have it set equal to 0, you see right away you could factor that. Go ahead and do that. That's going to be your quickest way. The square root principle is only when you have an x squared. There is no other x or variable in the problem. It's just x squared. So for example, I wrote the equation 2x squared plus 3 equals 9. There is no other x. So I'm just going to go ahead and use the square root principle, meaning I'm going to get x squared by itself, and then I'm going to take the square root of both sides. Easy peasy. You guys finish that homework with literally within like 15 minutes. Completing the square, we just recently learned, we know that that's not the easiest method to use, but it is important for you to understand it because we're going to use that in the next upcoming lessons when we start graphing conics. And then lastly, we're learning the quadratic formula, and that's good to use when factoring isn't very easy or your quadratic cannot be factored. You have to use the quadratic formula. Okay, and the last thing I want to talk about is your discriminant. So you could use your discriminant to determine the number and type of solutions that your equation has. Okay, so the discriminant is the radicand, so meaning it's what's inside of a radical, and it's, if you notice, b squared minus 4ac, that's what's inside of the radical of the quadratic formula. So inside of that is going to tell me how many solutions I'm going to have and what type. So, for example, if the number that I calculate out inside of my radical is bigger than 0, meaning I'm getting a positive number, no matter what, I'm going to get 2 real solutions. Okay, that makes sense because this is inside of the radical of a quadratic formula. So if the inside of your radical ends up being a positive number, you're going to get real solutions. Now, if it ends up equaling 0, which we saw an example, where are you? Right here. Inside of this radical ended up equaling 0. The b squared minus 4ac ended up being 0. What happened? I had one solution, one real solution. Okay, so if it ends up equaling it, I get one real solution. And now if it ends up being less than 0, so a negative number, which we saw right here, we calculated inside of the radical, it became negative 8. We notice we have an imaginary number and we have something with I. So we say, yes, there's no real solutions, but we do have 2 non-real complex solutions that we do know how to identify. Okay, so it doesn't mean that there's no solutions, it just means we have 2 non-real imaginary solutions. Okay, so in these examples, literally all I'm asking you is to use the discriminant to determine the type and number of solutions. I'm not even asking you to solve. So what you need to do is get this in standard form first, because you need to identify A, B, and C in order to plug it into the discriminant. So here's my A, here's my B, here's my C. So I'm going to plug it into b squared minus 4ac. Again, that's what's inside of your radical, so that's why it helps us determine what type of solutions we're going to have. And I want to see, what is this going to equal? So b squared is negative 7 squared. Again, keep that in parentheses. And then minus 4 times a times c. I'm going to calculate this out, so I get 49. So I have negative 4 times 3 times 8, which is positive 96. And I'm going to add that to 49, and I get 145. Well, that's a positive number. It's greater than 0, so that means, by looking at my chart, I have a positive number, so that means I have 2 real solutions. I don't care what they are. I just want you to be able to know, hey, I'm going to have 2 real solutions in this problem. Okay, I'm going to do the same thing in number 2. I need it to be in standard form. So I'm going to move everything over. And I'm going to identify A, B, and C. So A is 1, B is -4/5, and C is 4/25. Yay, we get to work with fractions. So I am going to plug in -4/5 squared minus 4 times A times C. And I want to see what does this end up equaling. So I get 16/25. Again, make sure that is positive. You're squaring a negative number. And then I get -8/25. Luckily, we already have common denominators, so I can combine right away. Okay, so I have 8/25, which is greater than 0. Oh my god, I just multiplied that wrong. Silly me. 4 times 4 is 16, not 8. So this actually ends up equaling 0. Since it equals 0, go back to your chart. That means I have a real solution, but I only have one of them. It's not telling me that my solution is 0. That certainly is not the case. It's just telling me that inside of that radical of the quadratic formula, it's going to equal 0, which is creating one real solution for me. Okay, so in number 1 over here, the answer is not 145. Please do not think x equals 145. Okay, this is telling me that if I were to plug this into the quadratic formula, inside of the radical, I would have the square root of 145, and I would end up getting two real numbers. I don't know what those answers are. It's just telling me you're going to have two real answers. Okay, and then lastly with number 3, this is already in standard form. So A is 0.5, B is -0.8, and C is positive 2.5. So again, I'm just plugging it into B squared minus 4AC. I want to know what's that going to equal. So -0.8 squared, keep it in the parentheses if you type it in your calculator, minus 4 times 0.5 times 2.5. Okay, so this is going to become 0.8 squared, 0.64 minus -4 times 2.5, that's 10, and then times 0.5, that's 5. So I have 0.64 minus 5, which is equal to -4.36. Again, my answer is not 4.36. It's saying in the quadratic formula, inside the radical, I would have the square root of -4.36, which is a negative number, which means my answer is going to give me two non-real complex solutions. I don't know what those are. I just know that they're not going to be real. They're going to be imaginary. So it's good to know the different types of solutions you're going to have, because our next lesson, we're actually going to be getting into graphing these parabolas. Okay, so when your discriminant ends up being greater than 0, so a positive number, you're going to have two real solutions. Okay, the solutions that you find when you're solving quadratics, when you find what x is equal to, you're finding where your graph crosses the x-axis. So if you have two real solutions, you're going to have two x-intercepts. So wherever these are crossing your x-axis, these are your solutions for x when you solve your equation. Okay, so if you use your discriminant and you find that it equals 0, that means you have one real solution, which means it's only going to cross the x-axis once. Usually you're going to have what we call is a double root. So your two answers are technically right here where your vertex is touching the x-axis. And then when your discriminant ends up being two non-real complex solutions, so a negative number, then it's not going to cross the x-intercept at all. So when you see a parabola just like floating in midair, not crossing your x-axis, that means that that equation of that parabola, when you solve that equation, you're getting two non-real numbers. Okay, I know this might be a lot to think about with the graphing wise, but it'll start making more sense when we actually start learning how to graph these.